Welcome to the lesson on coating, conditioning, and finishing. Upon completion of this lesson, learners will be able to explain the importance of coating, conditioning, and finishing in EV manufacturing. Learners will also be able to describe the different types of coating, conditioning, and finishing processes and recognize their applications in the automotive industry. Customers want the products they buy to be in good condition when they purchase them. Products such as automobiles may undergo many protective processes before they are fully assembled and sent to the customer. This helps improve the product's durability and aesthetic appeal. During manufacturing, workpieces must be protected and finished before they can be sent to the final assembly processes. Three methods that are commonly used to protect and alter workpieces are coating, conditioning, and finishing. We will discuss each in detail in the upcoming slides. Coating is the process of applying a layer of material on top of a workpiece. The coating process is performed to improve the appearance of the workpiece and to protect the material from corrosion and the environment. There are various methods of applying coatings to surfaces. Some methods for applying thin layers of coatings on workpieces include spraying, electrolysis, dipping, and vapor deposition. Spray painting of automobiles is an example of coating to improve the appearance of the car. Covering a copper ring with gold plating is a good example of the electrolysis method of coating. Automotive manufacturers employ various coating techniques to protect vehicle components. Some of the methods are listed here. The range includes electroplating for corrosion resistance and appearance on bumpers and wheels, e-coating to shield body panels and chassis from corrosion, and powder coating that delivers durable yet eco-friendly finishes for wheels and suspension parts. The painting process involves multiple layers. Paint primer ensures proper surface preparation and adhesion on body panels. Base coat adds color to exterior surfaces. And clear coat provides UV protection, gloss, and durability to all exterior painted surfaces. Ceramic coating provides protection through its hydrophobic properties, making it suitable for preserving paint, windows, and wheels while repelling water and contaminants. Let us look at the next method, conditioning. This is a process of changing the properties of materials in workpieces by applying heat, chemicals, and pressure. The main conditioning process is heat treatment. Heat treatment is a commonly used type of conditioning for metal workpieces. Heat treatment is the heating and cooling of metal to alter its properties. Knowledge about the heat treatment process is important in the manufacturing industry. Heat treatment changes physical properties like the workpiece's hardness, flexibility, and brittleness. Heat treatment involves various techniques, including annealing, quenching, and tempering. Let us take a closer look at the three techniques. Annealing is a heat treatment process to soften metal, relieve stress, and improve ductility. The process begins by heating the metal above its recrystallization temperature, typically 800 to 900 degrees Celsius for steel, where its internal structure can change. The metal is then held at this temperature to allow atomic rearrangement and stress relief, followed by slow cooling in a furnace or air to prevent new stresses. As a result, the metal becomes softer and more ductile, making it easier to machine while reducing hardness. Quenching is a rapid cooling process used to harden metals, particularly steel, after heating to high temperatures. The process begins by heating the metal to around 800 to 900 degrees Celsius, followed by rapid cooling in water, oil, or another cooling medium. This quick cooling prevents the formation of softer phases and instead creates harder structures like martensite. The resulting metal becomes harder but also more brittle as the rapid cooling locks the metal in a hardened state. This process is primarily used when hardness is the main requirement, such as in tools or knife blades. Tempering is a process used after quenching to reduce metal brittleness and adjust hardness. Following quenching, the metal is reheated to a lower temperature, typically 150 to 650 degrees Celsius, depending on desired properties, and held for a set period to allow the tempering process to occur, followed by air cooling. This process results in a metal that is tougher and less brittle, creating an optimal balance between hardness and ductility. Such balance is essential in applications where the metal must maintain strength while resisting cracking or breaking under stress. Heat treatment plays an important role in manufacturing various electric vehicle components to achieve specific mechanical properties and performance requirements. Some examples include motor shafts and bearings that need precise hardness for durability, high-strength chassis frame components, drive shafts that must withstand torque loads, axle components requiring wear resistance, and battery heat sink materials that need optimal thermal management properties. Finishing is the final process in manufacturing that removes small defects like scratches, blemishes, and stains. Finishing also enhances the appearance of products and provides texture, color, and smoothness. Finishing includes activities such as polishing, cleaning, and brushing. Here is a list of automotive surface finishing types used in manufacturing. Polishing creates a smooth, high-shine finish for body panels, trims, and wheels, while brushing adds decorative texture and conceals imperfections on interior trim, pedals, and door handles. Grinding prepares surfaces and removes defects on brake rotors, and shot blasting cleans surfaces and increases adhesion for frame components and suspension parts. Buffing achieves a high-gloss finish on painted surfaces and chrome parts, while sanding smooths and prepares body panels and filler areas. Texturing provides both non-slip functionality and aesthetic appeal for dashboards and interior plastics. In summary, manufacturing processes involve three key surface treatments: coating, which applies a protective layer of material on top of a workpiece; conditioning, which alters material properties through heat, chemicals, and pressure; and finishing, which eliminates surface defects such as scratches, blemishes, and stains. These processes play vital roles in automotive manufacturing by protecting components, improving performance, and ensuring both quality and aesthetic appeal of vehicle components. Thank you.